Drop a ball. Just drop it. Hold it out in front of you and let go. Watch it fall. It accelerates toward the ground, hits the floor, bounces maybe once or twice, and stops. Now tell me, what just happened? You will say gravity pulled the ball down. Newton said so. The earth has mass. The ball has mass. Mass attracts mass. The ball fell because the earth dragged it down with an invisible force, reaching up through the floor, through the air, through space itself, and yanking that ball toward the center of the planet. Everybody knows this. Your teacher told you this. Your textbooks told you this. Newton told you this 300 years ago, and nobody has argued with Newton since. Except one person did argue. And he did not just argue. He demolished the whole idea. He proved that Newton's beautiful picture of gravity, the one you learned in school, the one you think you understand, is fundamentally, completely, spectacularly wrong. The man who proved it was Albert Einstein. And what he discovered is so strange that even today, more than 100 years later, most people have never heard the real explanation. They go through their entire lives believing something about gravity that is simply not true. So here is what I am going to show you today. I am going to show you that gravity does not pull you down. I am going to show you that gravity is not a force at all. And I am going to show you what is actually happening right now to you, to the chair you are sitting in, to the planet beneath your feet. And I warn you, once you see it, you cannot unsee it. Let me start with a question that nobody asks. A question that seems stupid, but is actually the key to everything. When you drop that ball, the ball accelerates. It speeds up as it falls. We measure this acceleration on the surface of the Earth. It is 9.8 meters per second squared. Every physicist knows this number. Every engineering student has it tattooed on their brain. But here is the question. How does the Earth accelerate the ball? Think about this carefully. When you push a shopping cart, you touch it. Your hands make contact with the handle. Force travels through physical contact. When a car hits a wall, metal touches metal. When wind blows a leaf, air molecules crash into the leaf surface. Every force you have ever experienced in your daily life involves contact. Something touches something else, but gravity does not touch anything. The Earth does not reach up and grab the ball. There is no rope, there is no string, there is no beam of energy connecting the planet to the ball. The ball just falls. It accelerates toward the ground without anything touching it. Newton himself was deeply disturbed by this. He wrote that the idea of one body acting upon another through empty space without any medium was, and these are his exact words, so great an absurdity that no man with a competent faculty of thinking could ever accept it. Think about what Newton is saying. The man who invented the theory of gravity is telling you that his own theory is absurd. He is saying that it works mathematically, it predicts the motions of planets perfectly, but it does not make any sense. It describes what gravity does without explaining what gravity is. For 200 years, physicists swept this problem under the rug. The equations worked. The predictions were accurate. Nobody could offer a better explanation. So everyone just accepted the absurdity and moved on. And then Einstein came along. And Einstein did not accept absurdities. In 1907, Einstein was sitting in his office at the patent office in Bern, Switzerland. He was thinking about gravity, and he had what he later called the happiest thought of his life. It was a simple thought, almost childishly simple. But it changed everything. He imagined a man falling off a roof. Now that sounds terrible. A man falling off a roof is not usually associated with happiness. But Einstein was not thinking about the landing. He was thinking about the falling. He realized something astonishing. A man who is falling freely does not feel his own weight. During the fall, before he hits the ground, he is weightless. If he had a ball in his pocket and he took it out and let go of it, the ball would not fall away from him. It would float right there beside him, because the man and the ball are both accelerating at exactly the same rate. They are both in free fall together. Inside the experience of falling, gravity disappears. That thought shook Einstein to his core, because it told him something profound about the nature of gravity. It told him that gravity and acceleration are the same thing. Let me show you what Einstein saw. Let me build it up carefully, because this is where everything changes. Imagine you wake up inside a box, a sealed box with no windows. You cannot see outside. You have no idea where you are. You feel your feet pressing against the floor. You feel your weight. You drop a ball and it falls. Everything seems normal. You think you are standing in a room on the surface of the earth. But here's the thing. You might not be on Earth at all. You might be in a spaceship far from any planet, far from any star, out in the middle of empty space where there is no gravity at all. But the spaceship is accelerating. Its engines are firing, and it is accelerating upward at exactly 9.8 meters per second squared. Inside that accelerating spaceship, everything feels exactly like gravity. Your feet press against the floor. You feel your weight. You drop a ball and it falls. You pour water from a glass and it streams downward. You jump and you come back down. There is no experiment you can do inside that box to tell the difference. None. Not with any instrument, not with any measurement, not with any cleverness at all. The experience of standing on the earth and the experience of accelerating through empty space are physically, measurably, absolutely identical. Einstein called this the equivalence principle. And it is not just a thought experiment. It is not just a philosophical game. It is a fundamental law of nature. Gravity and acceleration are not similar. They are not analogous. They are the same phenomenon. Now think about what this means. Think about it carefully, because this is where your brain is going to resist. If gravity and acceleration are the same thing, then what you feel right now, the weight pressing you into your chair, might not be gravity pulling you down at all. It might be acceleration pushing you up. And that is exactly what Einstein proved is happening. You are not being pulled down by gravity. The ground is being pushed up into you. The chair is accelerating upward into your body. The floor is rushing up to meet your feet. You are not falling. You are being hit. Now you will say, that is insane. I am sitting perfectly still. The ground is not moving. The chair is not moving. Nothing is accelerating. I am stationary. But are you? Let me tell you what Einstein discovered about space and time, and I warn you, this is the part that bends your mind into shapes it was not designed to hold. Einstein showed that mass does something to space, not to the objects in space, to space itself. Mass bends space. Mass warps the fabric of the universe. Think of a heavy bowling ball placed on a stretched rubber sheet. The ball sinks down and creates a curved depression. The sheet is no longer flat around the ball. It is curved, deformed, warped. Now roll a marble across that sheet. The marble does not travel in a straight line. It curves toward the bowling ball. Not because the bowling ball is pulling it. The bowling ball is not reaching out and grabbing the marble. The marble curves because the sheet itself is curved. The marble is following the shape of the surface it is rolling on. This is what the earth does to space. The earth does not reach out and pull you down. The earth bends the space around it, and you move through that curved space. What you interpret as a force pulling you down is actually the curvature of space directing your path. But wait, it is not just space that curves. Einstein showed that mass curves time as well. And this is where it gets truly strange. Time runs at different speeds depending on where you are in a gravitational field. If you are standing on the surface of the earth, your feet are closer to the center of the planet than your head. The gravitational field is slightly stronger at your feet. And Einstein's theory says that time runs slightly slower at your feet, than at your head. This is not a metaphor. This is not poetry. This is measurable fact. We have tested it with atomic clocks. We have put one clock on the ground floor of a building and another clock on the top floor. The clock on the ground floor runs slower by a tiny amount, yes, by a fraction of a nanosecond per day, but it is real, it is measured, it is certain. Your feet are aging slower than your head right now as you sit there. And here is the mind-bending part. This difference in the flow of time is what creates the sensation you call gravity. Objects naturally move through time. Everything moves through time. You are moving through time right now at roughly the speed of light. That sounds strange, but it is true. When you are standing still in space, all of your motion is through time. You are hurtling forward in time at tremendous speed. But if time flows at different rates in different places, then this forward motion through time gets bent, it gets deflected, it gets curved toward the region where time runs slower, toward the massive object, toward the earth. This is gravity, not a force pulling you down, but the curvature of time directing your natural motion through the universe toward the ground. You do not fall because the earth pulls you. You fall because time is bent. Now I know your head is spinning. I know this sounds impossible. Time is bent. Time runs slower near the ground. That is what makes things fall. How can that be? How can the ticking of a clock have anything to do with an apple falling from a tree? Let me try one more way to explain it, because I think this is the most important idea in all of physics, and I want you to carry it with you when you leave here tonight. Think about two ants walking side by side on a flat table. They start at the same point. They both walk straight ahead, parallel to each other. They stay the same distance apart forever. Their paths never cross. Their paths never diverge. Straight lines on a flat surface stay parallel. Now take those same two ants and put them on a basketball. Put them both at the top of the ball right next to each other. Tell them to walk straight ahead. They both walk in perfectly straight lines. Neither one turns. Neither one curves. They walk as straight as they possibly can. But what happens? Their paths converge. They get closer and closer together, and eventually they meet at the other side of the ball. Neither ant turned. Neither ant was pushed. Neither ant was pulled by the other. They both walked in perfectly straight lines, but the surface they were walking on was curved, and on a curved surface, straight lines converge. This is gravity. The earth is not pulling the apple down. The apple is moving in a straight line through curved space-time. Space-time near the earth is warped, bent, deformed by the earth's mass. And a straight line through warped space-time looks, to us, like a curve. It looks like falling. The apple is not being pulled. The apple is following the straightest possible path through the curved geometry of the universe. Physicists call this path a geodesic. It is the equivalent of a straight line on a curved surface. When you throw a ball and it arcs through the air and comes back down, you see a curve. You see a parabola. You think a force is bending its path. But in the four-dimensional fabric of space-time, that ball is traveling in a straight line. It is the space-time itself that is curved, and that curvature creates the illusion of a force. Gravity is geometry. Gravity is the shape of the universe. Gravity is the curvature of the stage on which all of physics plays out. Now let me take you back to where we started. You are sitting in your chair. You feel your weight. You feel gravity pulling you down, but now you know the truth. Nothing is pulling you down. Here is what is really happening. You right now are trying to follow a geodesic. Your natural path through space-time is a free fall path. You want to fall. That is your natural state. Free fall is the natural state of everything in the universe. Falling is not something that happens to you. Falling is what you are supposed to be doing, but the chair will not let you. The chair is in the way. The atoms in the chair are pushing against the atoms in your body. Electromagnetic forces between the electrons in the chair surface and the electrons in your clothing are shoving you upward. The chair is accelerating you away from your natural path. That is what you feel, that sensation of weight, that heaviness, that constant pressure. It is not gravity pulling you down, it is the chair pushing you up. It is the ground refusing to get out of your way. It is the electromagnetic force of solid matter preventing you from following your geodesic. You are not being pulled toward the earth. You are being prevented from falling freely through curved space-time. If the chair disappeared right now, if the floor vanished, if everything solid around you ceased to exist, you would fall. And in that fall, you would feel weightless. You would feel nothing, no force, no pull, no push, just peace, just silence, just the natural motion of a body following the curvature of the universe. Astronauts in the space station experience this. They float. They are weightless. People say they are in zero gravity, but that is wrong. The gravity at the space station is almost as strong as it is on the ground. The station orbits at only 400 kilometers above the Earth. The gravitational field there is about 90% as strong as on the surface. The astronauts are not in zero gravity. They are in free fall. They are falling toward the Earth every single second, but they are also moving sideways so fast that the Earth curves away beneath them at exactly the same rate they fall, so they keep falling and never hit the ground. They are in a perpetual state of falling, and because they are falling freely, because nothing is pushing them away from their geodesic, they feel weightless. They feel no gravity, because gravity is not a force that acts on them. Gravity is the curvature of space-time, and they are following that curvature perfectly. So here is the truth that Newton glimpsed but could not prove, the truth that Einstein spent 10 years of his life working out, the truth that most people never learn, even though it changes the meaning of everything you feel every moment of every day. Gravity does not pull you down. Gravity is not a force. Gravity is the shape of time and space around massive objects. What you feel as weight is not gravity acting on you. It is the ground acting on you. It is the floor hitting you from below. It is the Earth's surface accelerating upward into your feet at 9.8 meters per second squared. You have been falling your entire life, and the ground keeps getting in the way. The next time you sit down, the next time you feel that familiar heaviness, that constant pull, I want you to remember what it really is. It is not the earth pulling you toward it. It is the chair refusing to let you follow the straightest path through the curved universe. You are not heavy because gravity drags you down. You are heavy because something keeps stopping you from falling, and falling is the most natural thing in the universe.